In a thrilling new development that has left the astronomical community buzzing, the James Webb Space Telescope, JWST, has uncovered some groundbreaking insights into Betelgeuse, one of the most iconic stars in the night sky. Betelgeuse, the enormous red supergiant located in the constellation Orion, has long intrigued astronomers due to its immense size, unpredictable behavior, and eventual fate. But now, thanks to the unparalleled capabilities of JWST, a new chapter in this star's story is unfolding, one that promises to change how we understand the lives and deaths of stars. Betelgeuse has always been a star of mystery and fascination. It's nearing the end of its life cycle, and will eventually explode as a supernova, a process that could light up the sky for weeks. For years, Betelgeuse has shown odd fluctuations in its brightness, with one particularly noticeable dimming event in 2019 and 2020 that led many to speculate it was about to go supernova. That event, while intriguing, ultimately faded, leaving us with more questions than answers. But now, the story has taken a new twist. Recently, Betelgeuse's brightness surged by an astonishing 250%, sparking a flurry of excitement and confusion among scientists. Such a dramatic increase is unprecedented for this star, and it challenges our current understanding of how red supergiants behave in their final stages. This sudden rise in light raises questions about what's happening deep inside the star, and whether it's a sign that the long-awaited supernova is finally approaching. While it's widely accepted that Betelgeuse will end its life in a spectacular explosion, pinpointing when exactly that will happen remains one of the biggest challenges in astrophysics. A star like Betelgeuse could blow up tomorrow, or it could burn for tens of thousands of years. But the recent change in its brightness, unlike any typical fluctuations seen in stars of its kind, has astronomers wondering if we are witnessing a crucial stage in its evolution, perhaps a prelude to its final collapse. JWST's powerful infrared imaging capabilities have given scientists a never-before-seen view of Betelgeuse's inner workings. Unlike optical telescopes, which are limited by the dust and gas surrounding stars, JWST's infrared sensors can peer through these obstacles, providing a clearer picture of the star's internal processes, surface temperature, and overall activity. This level of detail is revolutionizing our understanding of how stars like Betelgeuse behave, especially in the lead-up to their explosive end. With these new insights, scientists are diving deep into what might be driving this sudden surge in brightness. Is it due to an internal convective surge, where hot plasma from the core is rapidly brought to the surface, releasing massive amounts of energy? Or is something else at play, perhaps a complex interaction with the cosmic medium surrounding the star? The truth remains elusive, but the possibilities are captivating. What makes Betelgeuse so fascinating is that it's one of the closest red supergiants to Earth, located just 640 light-years away. This proximity offers a rare opportunity for astronomers to study it in great detail, a privilege that's not afforded with many other stars in the galaxy. As a result, Betelgeuse has become an essential star for understanding the larger processes of stellar evolution, especially for stars on the brink of a supernova. JWST's ability to capture high-resolution infrared images allows scientists to witness the changes taking place inside the star in ways that were previously impossible. For instance, the massive rise in brightness could be signaling a shift in the internal processes at the heart of Betelgeuse, possibly related to the star's core instability or changes in its magnetic field. For decades, scientists have studied red supergiants like Betelgeuse, knowing that these massive stars burn through their fuel at a rapid rate and explode in a brilliant burst of light when their nuclear fuel runs out. However, exactly how this process unfolds has remained shrouded in mystery. The massive surge in brightness we're now witnessing could be linked to a phase of the star's evolution that we haven't fully understood yet. In particular, astronomers are considering the possibility that Betelgeuse is undergoing much larger and more energetic convective currents within its core. These convection currents, which cause hot plasma to rise to the surface and cool before sinking back down, are common in massive stars, but they've never been observed on the scale that Betelgeuse might be experiencing. If this is indeed the case, it could offer new clues about how such stars behave in their final years, and potentially explain why their light fluctuates in ways that have puzzled scientists for so long. Moreover, the sudden increase in Betelgeuse's brightness could signal that we're nearing the end of its life. In the final stages of a star's existence, when the core collapses under its own weight, the outer layers are ejected in a supernova explosion that releases an unfathomable amount of energy. Such an event would be visible even in the daytime, casting shadows across the Earth and providing astronomers with the rare opportunity to study a supernova in real time. For decades, scientists have been eagerly anticipating this moment, but predicting when it will happen has proven to be an impossible task. Betelgeuse's current surge in brightness is one of the first signs that we might be on the verge of witnessing such an extraordinary event. While it's still unclear when Betelgeuse will explode, the dramatic change in its brightness has led many to speculate that the star may be entering the final stages of its life cycle. If this is the case, it could provide an invaluable opportunity for astronomers to study a star just before it reaches its explosive end. The data gathered from such an event could provide insights into the processes that govern supernovae, which are crucial for understanding the formation of neutron stars, black holes, and the distribution of heavy elements in the universe. These elements are vital to the formation of planets and even life itself, which is why studying supernovae is so important. What makes this discovery even more exciting is that it may also help astronomers improve their understanding of how stars like Betelgeuse evolve as they approach the end of their lives. The increase in brightness could be linked to deep changes happening within the star's core, including the mixing of heavier elements like carbon, oxygen, and helium. These changes in the core could create shifts in the star's outer layers, altering its light output and causing the star to brighten dramatically. Another theory is that the increase in brightness might be connected to a change in the star's magnetic field, which could alter the behavior of the outer layers of the star, making certain areas shine more brightly. While there is still much we don't understand, the rise in Betelgeuse's brightness has opened up exciting new possibilities for the study of stellar evolution. Thanks to the incredible capabilities of the James Webb Space Telescope, we now have a much clearer view of the processes happening inside this massive star. As JWST continues to observe Betelgeuse, astronomers will be able to track the changes in its structure, temperature, and activity, providing critical insights into how massive stars evolve and how they eventually explode in supernovae. This, in turn, will help scientists refine their models of stellar death and better predict when other stars might meet a similar fate. The discovery of Betelgeuse's sudden brightening also emphasizes the importance of collaboration in modern astronomy. While the James Webb Space Telescope is a powerful tool, it's only one piece of the puzzle. By combining data from multiple sources, ground-based telescopes, other space observatories, and even previous observations of Betelgeuse, astronomers can build a more complete picture of what's happening inside this enigmatic star. As we continue to study Betelgeuse and other stars like it, we're not just uncovering the secrets of a single star, but gaining insights into the fundamental processes that govern the lives and deaths of stars across the universe. In the grand scheme of the cosmos, Betelgeuse's rise in brightness is a small but significant piece of the puzzle. It serves as a reminder that the universe is constantly evolving and changing, and that there is still so much to learn. Whether or not Betelgeuse's brightening is the precursor to a supernova, it's clear that this discovery has deepened our understanding of the universe and the forces that shape it. As scientists continue to study this extraordinary star, they will undoubtedly uncover even more surprises, revealing the mysteries of stellar